Hello friends, welcome back to this tutorial. Our next topic is NFA to DFA conversion. One thing which I would like to tell you about finite automata is finite automata accept only regular languages. Regular languages is a type of language, right? And finite automata accept only regular languages. For each automata, we have a language associated with it. And that language is the set of string which is accepted by that automata. Suppose we have two automatas M1 and M2 and their languages LM1 and LM2 respectively. Then these two automata would be equivalent if their language is same, which means LM1 equals to LM2. It means both accept same set of strings. NFA and DFA both have same power. It means if a language is accepted by a NFA, then the same language can be accepted by a DFA. It means if we have a NFA, we can construct a DFA equivalent to that NFA. Now, NFA to DFA conversion. It is also known as subset construction. Now, how we do it? It includes few steps. First step is to take the initial state of NFA. Initial state of NFA would be the initial state of DFA. Now find the transition of this initial state for all possible input symbols, right? One thing you must remember, when you apply any input symbol to a state of NFA, the output would be a set of possible states, right? Now, when you apply any input symbol to this initial state of NFA, you will get a set of possible states, right? And then make this set of possible state as a single state of a DFA, right? So what you have to do, whatever set you get after applying an input symbol on a state, you have to make that set a single state of a DFA. Next is, then when you get new states after applying input symbol, find the transition of these new states in same way and repeat this procedure until there are no more new states, right? So it would be more clear when we convert this NFA into DFA. Here we have an NFA which has three states, Q0, Q1 and Q2. Its transitions are also mentioned here. It is shown in this graph that it has only two input symbols, 0 and 1, right? Now what I have told you earlier, take initial state as it is. So Q0 would be the initial state of DFA. Now find its transition for all possible input symbols. So when you apply 0 to Q0, the output would be a Q0, Q1, right? When you apply 0 to Q0, output would be a Q0, Q1. Then make it a single state of DFA. Now here it is this whole set is a single state of DFA. And we will label this transition with input symbol 0 because in NFA we got this set after applying the input symbol 0. So here label it with 0. Now find the transition for input symbol 1. When you apply 1 to initial state, the output would be Q0. It means machine would remain in same state when we apply 1, right? Now we have got a new state that is a set Q0, Q1. Now we have to find its transition for all possible input symbols. First of all, find it for input symbol 0. Delta set Q0, Q1 for input symbol 0, right? How could we find apply this input symbol individually to each state of the set. That would be delta Q00 union delta Q1 0. Right? It is a union symbol. Delta Q0 would be set Q0 Q1. And when you apply 0 to Q1, there is no transition. It would be Q0 Q1. So when you apply 0, it will remain in same state Q0 Q1. Now for the input symbol 1. Delta Q0 Q1 for input symbol 1. First of all, apply 1 to initial state Q0, then apply 1 to next second state of this set Q1. So it would be delta Q01 union delta Q1 1. Right? For Q1 we have only for 1 there is one transition from state Q0, that is only to Q0. So it would be Q0. And you can see when we apply 1 to Q1, the next state would be Q2. There is only one state, and their union would be Q0 Q2. Q0 Q2. So when we apply 1 here, we will get a next state Q0 Q2. Right? Now find the transition of this new state Q0 Q2 for input symbol 0 and 1. Apply 0 individually to each state of the set Q0 and Q2. When you apply 0 to Q0, the result would be a set Q0 Q1. When you apply Q2 0 to Q2, the result would be 5 set, because there is no transition for input symbol 0 from state Q2. So it would be Q0 and Q1. It means when you apply 0, it will jump to state Q0 Q1. Now we have to find its transition for input symbol 1. Again, same manner, Q0 Q2. Apply 1 individually to each state of the set, delta Q0 1 and union delta Q2 1. When you apply 1 to Q0, it will remain in state Q0, and when you apply 1 to Q2, there is no transition. So it will result in set having only Q0. So when we apply 1, it will jump to Q0. Now we have to find out the final state of this DFA. Now look at here. NFA has a final state Q2. Now check which state of DFA contains the final state of NFA. If any state of DFA contains final state of NFA, then make that state of DFA as a final state. Here this state contains the final state of NFA. So we will make it the final state of DFA. So this DFA is equivalent to this NFA. So which string is accepted by this NFA? The same string will be accepted by this DFA. Which string is rejected by this NFA? The same string will be rejected by this DFA. Thank you very much.